July 18, 1944, St. Vith Sector, Normandy, 08:47 hours. The morning mist clings to the hedgerows as Obergefreiter Klaus Weber adjusts his periscope inside his Panzer IV. Through the haze, he watches an American Sherman tank sitting motionless in the field below, smoke trailing from its engine compartment. The tank took a direct hit from his gunner 20 minutes ago, a clean shot that should have sent the crew scrambling for safety. But something is wrong with this picture. Instead of abandoning their machine, 3 American soldiers are crawling beneath the disabled Sherman. One emerges with a wrench, calling out instructions Weber cannot understand. Another disappears into the engine bay while mortar rounds whistle overhead, impacting barely 50 meters away. Weber's commander, Lieutenant Hoffman, leans forward in disbelief. "What are they doing?" he whispers through the intercom. "That tank is finished." The Americans work with methodical precision despite the artillery barrage. One mechanic slides a replacement part from a nearby half-track, while his comrade continues working inside the smoking engine compartment. Shell fragments ping off the Sherman's hull, but the men never pause. Then, the impossible happens. The Sherman's engine coughs to life, black smoke clears to white exhaust. The turret traverses left, then right, testing its systems. Within minutes, the destroyed tank is moving again, backing toward American lines with its crew intact. Weber stares through his scope, watching the Sherman disappear into the morning fog. In 18 months of combat across Russia and France, he has never seen anything like this. German doctrine is clear. Damaged tanks retreat for proper repair or are abandoned. Yet these Americans have just performed battlefield surgery under fire. "Mein Gott," Hoffman mutters. "How is this possible?" Neither German tanker realizes they've just witnessed America's secret weapon, not superior firepower or thicker armor, but something the Wehrmacht never anticipated: the ability to bring dead tanks back to life in the middle of battle. The philosophy behind tank maintenance in World War II revealed fundamental differences between American and German military thinking. When German tank crews encountered disabled vehicles on the battlefield, their training dictated immediate withdrawal to specialized repair facilities. This wasn't cowardice, it was doctrine born from engineering perfectionism and industrial limitations. German tanks like the Panzer IV, Panther, and Tiger were marvels of mechanical precision. Each component was machined to exact specifications, fitted with specialized tools, and designed for optimal performance rather than field serviceability. The Tiger tank's transmission alone required 48 hours of careful disassembly by trained technicians. German maintenance manuals read like engineering textbooks filled with precise measurements, specialized procedures, and warnings against improvised repairs. This approach reflected Germany's pre-war industrial philosophy. German engineers built machines to last decades, not months. They assumed their tanks would operate from established bases with proper workshops, skilled mechanics, and unlimited time for proper repairs. The concept of battlefield maintenance seemed not just impractical, but dangerous. Hastily repaired equipment might fail at critical moments, endangering the entire crew. The German Army's maintenance structure reinforced this philosophy. Each panzer regiment included a maintenance company equipped with sophisticated tools, precision instruments, and highly trained specialists. These men could rebuild engines, machine replacement parts, and perform complex electrical repairs. But they required static positions, proper facilities, and extended time periods to work effectively. Recovery procedures followed strict protocols. When a German tank suffered mechanical failure or combat damage, recovery vehicles would evacuate it to battalion maintenance areas, typically several kilometers behind the front lines. There, specialists would assess the damage, order specific replacement parts, and perform repairs according to factory specifications. This process often took days or weeks, but it ensured maximum reliability when the tank returned to service. German training emphasized perfection over speed. Mechanics learned to diagnose problems through systematic testing, replacing entire assemblies rather than attempting field expedients. Tank crews received minimal mechanical training beyond basic operation and preventive maintenance. The philosophy was simple: operators operate, mechanics repair, and never shall the two roles overlap. This system worked brilliantly during Germany's early campaigns. The Polish and French campaigns lasted only weeks, providing ample time for proper maintenance between battles. German T. Tanks dominated not through superior numbers but through mechanical reliability and precision engineering. Each machine represented months of careful craftsmanship, and losing one unnecessarily seemed wasteful. But the Russian campaign shattered these assumptions. Distances measured in thousands of kilometers, temperatures dropped below -40 degrees Celsius, and combat continued for months without respite. German maintenance companies found themselves overwhelmed by demands they never anticipated. The careful, methodical approach that worked in peacetime exercises proved inadequate for sustained combat operations. By 1942, German tank availability rates dropped catastrophically, not from enemy action primarily, but from mechanical failures that couldn't be repaired quickly enough to keep pace with operational demands. Perfect tanks sitting in repair shops couldn't influence battles being fought hundreds of kilometers away. The German obsession with engineering perfection had created a vulnerable dependency on specialized maintenance that couldn't adapt to battlefield realities. Meanwhile, across the Atlantic, American engineers approached tank design with entirely different assumptions about warfare, maintenance, and human capability. American tank development emerged from pragmatic industrial experience rather than military tradition. Henry Ford's assembly line philosophy influenced every aspect of Sherman tank design: standardized components, interchangeable parts, and repair procedures simple enough for factory workers to master quickly. Where German engineers sought perfection, Americans pursued reliability through simplicity. The Sherman tank embodied this philosophy from its inception. Every major component was designed for rapid replacement by semi-skilled technicians using common tools. The engine bay opened with standard wrenches, electrical systems used automotive-grade components available at any motor pool, and transmission assemblies could be swapped in hours rather than days. American engineers assumed tanks would break down frequently and designed them to be fixed by ordinary soldiers under adverse conditions. This approach reflected American industrial culture. Detroit automakers had spent decades perfecting mass production techniques that prioritized speed and standardization over individual craftsmanship. When tank production began, these same principles guided design decisions. Components were manufactured in vast quantities, tested for compatibility across multiple tank models, and distributed through supply chains designed for rapid deployment. American tank crews received extensive mechanical training as part of their basic preparation. Unlike their German counterparts, Sherman operators learned to diagnose engine problems, replace track sections, repair electrical faults, and perform complex maintenance procedures. The assumption was simple: in extended combat, crews must be capable of maintaining their own equipment without relying on specialists. The American maintenance philosophy embraced improvisation as a virtue rather than a vice. Field manuals encouraged creative solutions using available materials. Tank crews learned to fabricate replacement parts from salvage components, jury-rig damage systems using expedient repairs, and keep their machines operational through ingenuity rather than perfect engineering. This approach horrified German observers, but proved devastatingly effective in practice. American maintenance organization reflected these priorities. Each tank company included organic maintenance detachments equipped with portable tools, welding equipment, and stocks of common replacement parts. These units were designed to operate forward, often within direct fire range of enemy positions. Their mission was simple: keep tanks fighting rather than preserve mechanical perfection. Recovery procedures emphasized speed over precision. When American tanks suffered damage, recovery teams immediately assessed whether repairs could be completed quickly enough to return the vehicle to action. If so, mechanics would begin work immediately, often while the battle continued around them. Components were replaced rather than repaired, entire assemblies swapped out in minutes using standardized mounting points. The contrast became apparent during the North African campaign. German tankers observed American recovery teams working under artillery fire, replacing entire engines in forward positions while battles raged nearby. This seemed not just dangerous but nonsensical. Why risk valuable technicians and equipment for hasty repairs that might fail? But American commanders understood something their German counterparts didn't grasp. In mobile warfare, immediate tank availability mattered more than long-term mechanical perfection. A Sherman repaired quickly and returned to battle could influence combat outcomes, even if it required additional maintenance later. Perfect tanks sitting in rear area workshops contributed nothing to tactical success. Training emphasized this philosophy. American tank crews practiced emergency repairs under simulated combat conditions, learning to work efficiently while under stress. They memorized component locations, practiced replacement procedures until they became automatic, and developed confidence in their ability to maintain their equipment independently. The psychological impact proved as important as the mechanical advantages. Sherman crews knew they could repair most damage themselves, reducing dependence on rear area support and increasing their willingness to accept combat risks. German tankers, conversely, understood that significant damage meant immediate withdrawal from action, encouraging cautious tactics that limited their offensive effectiveness. By 1943, these philosophical differences had created stark operational contrasts that would define tank warfare for the remainder of the war. From a technical perspective, Sherman tanks possessed inherent advantages that made battlefield repair feasible. The M4's radial aircraft engine was designed for automotive mechanics rather than specialized technicians. Unlike the complex German power plants with their precision machine components and specialized tools, the Sherman's Continental R975 used standard automotive parts available through normal supply channels. Spark plugs, oil filters, and engine components could be requisitioned from any motor pool or even salvaged from destroyed vehicles. The Sherman's modular design philosophy extended throughout its construction. Major assemblies connected through standardized mounting points that could be disconnected using common tools. The transmission, final drives, and differential assemblies were designed as replaceable units rather than permanently integrated components. This meant mechanics could swap out entire systems in hours rather than attempting complex internal repairs under battlefield conditions. Electrical systems reflected American automotive experience. Sherman tanks used 12-volt systems with components identical to those found in civilian vehicles. Alternators, starter motors, and wiring harnesses could be replaced using parts from trucks, jeeps, or even civilian automobiles. German tanks, by contrast, employed specialized electrical components that required factory-specific replacements unavailable through field supply channels. The human element proved equally crucial. American tank crews averaged higher mechanical aptitude than their German counterparts due to different recruitment philosophies. The United States Army actively sought men with automotive experience, mechanical training, or industrial backgrounds for armored units. Many Sherman operators had worked in factories, repair shops, or farms where mechanical problem-solving was routine. They approached tank maintenance with confidence born from practical experience. German tank crews, conversely, were selected primarily for their military bearing and tactical competence. Technical specialization was concentrated among designated mechanics and technicians, creating artificial barriers between operators and maintenance personnel. Tank commanders might possess extensive tactical knowledge but lack the mechanical understanding necessary to diagnose simple engine problems. Training methodologies reinforce these differences. American tank schools dedicated significant time to mechanical instruction, requiring all crew members to demonstrate competence in basic repair procedures. Students learned to replace engines, troubleshoot electrical faults, and perform complex maintenance tasks as part of their standard preparation. German training, by contrast, emphasized tactical employment and left detailed mechanical work to specialists. The psychological dimension cannot be understated. American crews developed confidence in their ability to solve mechanical problems through improvisation and creativity. They were encouraged to experiment, modify equipment to meet specific needs, and find solutions using available materials. German crews were trained to follow procedures precisely, avoid unauthorized modifications, and defer to technical authority when problems arose. Supply chain philosophies reflected these different approaches. American logistics emphasized rapid delivery of standardized components in large quantities. Sherman parts were manufactured in multiple facilities, shipped to forward depots, and distributed through flexible networks designed to respond quickly to battlefield demands. German supply chains prioritized precision and quality control, ensuring perfect components but creating bottlenecks when demand exceeded carefully planned production schedules. The tactical implications were profound. Sherman crews could accept higher mechanical risk because they possessed confidence in their repair capabilities. They were willing to push equipment beyond normal operational limits, knowing they could probably fix whatever broke. German crews, lacking this mechanical confidence, operated more conservatively to avoid breakdowns that would require specialized attention. Maintenance under fire represented the ultimate test of these competing philosophies. American crews had practiced emergency repairs in realistic conditions, developing the skills and confidence necessary to work effectively while under enemy observation. They understood which repairs could be completed quickly, which components were most likely to fail, and how to prioritize work to maximize tactical effectiveness. German doctrine discouraged such practices as unnecessarily dangerous and counterproductive. The risk of losing valuable personnel and equipment to enemy fire seemed to outweigh any potential tactical advantages from hasty repairs. This conservative approach made perfect sense within German operational philosophy, but created significant disadvantages when facing opponents willing to accept higher risks for immediate tactical gains. From the German perspective, American battlefield maintenance practices initially seemed reckless and unprofessional. Veteran panzer crews watching Sherman recovery operations through their periscopes witnessed behavior that contradicted everything they understood about proper tank maintenance. Soldiers working on engines while under artillery fire appeared desperate rather than competent, suggesting American equipment was so unreliable that constant emergency repairs were necessary for basic operation. German tank commanders reported these observations to higher headquarters with mixture of contempt and confusion. How could the Americans maintain any semblance of mechanical reliability when their crews performed hasty repairs using improvised methods? Surely these expedient fixes would fail at critical moments, leaving American tanks stranded during crucial battles. The German emphasis on engineering perfection suggested that shortcuts in maintenance would inevitably lead to catastrophic mechanical failures. But combat experience gradually revealed the truth. Those hastily repaired Sherman tanks kept returning to battle, day after day, often outlasting German machines that had been maintained according to factory specifications. American tanks that should have been permanently disabled were appearing in subsequent engagements, apparently suffering no long-term consequences from their emergency repairs. This contradiction challenged fundamental German assumptions about mechanical reliability and proper maintenance procedures. The moral dimension troubled German observers almost as much as the tactical implications. American willingness to risk valuable personnel for equipment recovery suggested either desperate shortage of tanks or complete disregard for human life. German doctrine emphasized that trained crews were more valuable than individual machines. Tanks could be replaced, but experienced personnel could not. Why would American commanders expose skilled mechanics to enemy fire for machines that could be replaced through normal production? Intelligence reports attempted to explain American behavior through industrial capacity arguments. Perhaps the Americans possessed such overwhelming production advantages that individual tank reliability became irrelevant. If replacement vehicles were readily available, emergency repairs might represent efficient resource allocation rather than desperate necessity. This explanation satisfied some German analysts, but failed to account for the obvious competence displayed by American maintenance personnel. Cultural factors played significant roles in German incomprehension. Traditional German military culture emphasized hierarchy, specialization, and adherence to established procedures. Officers commanded, specialists maintained equipment, and enlisted personnel operated machines within clearly defined roles. The American practice of cross-training personnel and encouraging improvisation seemed chaotic and undisciplined. The innovation aspect proved particularly disturbing to German observers. American crews routinely modified equipment, fabricated replacement parts, and developed expedient solutions to mechanical problems. German regulations strictly prohibited unauthorized modifications, viewing them as potential safety hazards and warranty violations. The American embrace of field modifications suggested either inadequate engineering or dangerous disregard for proper procedures. Psychological warfare implications became apparent as American battlefield maintenance capabilities influenced German tactical decisions. Panzer commanders who had previously counted disabled Sherman tanks as permanent kills discovered their opponents returning to action unexpectedly. This uncertainty complicated German planning and forced more conservative tactical approaches to ensure genuinely decisive kills rather than temporary mission kills. The propaganda dimension added another layer. Year of complexity. German military publications portrayed American equipment as inferior and poorly maintained, requiring constant repair due to shoddy manufacturing. But frontline reports contradicted this narrative, describing American tanks that continued operating despite damage that would have disabled German vehicles. This disconnect between official propaganda and battlefield reality created confusion and doubt among German personnel. Resource allocation questions troubled German logistics officers. If American crews could maintain their equipment independently, traditional German advantages in maintenance organization and technical expertise became less relevant. German panzer divisions required extensive rear area support, specialized tools, and time-consuming repair procedures. American units seemed capable of sustained operations with minimal logistical support, creating significant tactical flexibility. The learning curve proved steep for German forces. Units that had dominated earlier campaigns through superior training and equipment maintenance found themselves facing opponents who refused to accept mechanical defeat. American tanks that should have been abandoned or destroyed kept reappearing in combat, often with visible signs of hasty repairs, but apparently full operational capability. By late 1944, experienced German tank commanders had developed grudging respect for American battlefield maintenance capabilities, even if they couldn't fully understand the methods involved. These mysterious American mechanics who worked under fire had become part of the tactical equation, forcing German units to account for higher-than-expected American tank availability in their operational planning. The true test of American battlefield maintenance philosophy came during the Battle of the Bulge in December 1944. Hitler's last great offensive caught American forces unprepared, with German panzer spearheads smashing through thinly held lines in the Ardennes forest. Traditional military logic suggested this would be disaster for American armored units, scattered tank companies facing concentrated German attacks far from their normal supply bases and maintenance facilities. But something unprecedented happened in those frozen Belgian forests. As German panzers advanced through the snow-covered hills around Bastogne, they encountered American tank units that refused to die. Sherman tanks hit by German fire would disappear into the tree lines, only to reappear hours later with hastily welded armor patches and jury-rigged repairs. American mechanics worked in temperatures that froze lubricants solid, using blowtorches to thaw engine blocks while German artillery searched for their positions. Staff Sergeant Michael Kowalski of the 4th Armored Division's maintenance company founded himself performing miracles in a frozen forest, clearing near Martelange. His Sherman had taken a direct hit from a Panther tank that shattered the transmission housing and severed hydraulic lines throughout the turret system. By German standards, this damage required complete factory rebuilding, a multi-week process impossible under combat conditions. Kowalski saw the situation differently. Working by flashlight in sub-zero temperatures, he and 2 crewmen dismantled the damaged transmission housing using hammers and cold chisels when the wrenches froze solid. They fabricated a replacement housing from salvaged steel plate, welding it piece by piece while German flares illuminated the sky overhead. Hydraulic lines were spliced using compression fittings cannibalized from destroyed vehicles, and the entire turret traverse system was rewired using automotive components stripped from a knocked-out half-track. The repair took 14 hours of continuous work in conditions that should have made complex mechanical procedures impossible. When Kowalski's crew fired up their reconstructed Sherman at dawn on December 23rd, German observers watching through binoculars witnessed something their training insisted was impossible. A tank that had been definitively destroyed was moving again, backing out of the forest with its main gun trained on German positions. Similar scenarios played out across the Bulge battlefield. American maintenance crews established forward repair points in abandoned barns, church basements, and forest clearings within artillery range of German positions. They worked through concentrated bombardments, often welding armor plates while fragments peppered the ground around them. German intelligence officers collecting battlefield reports struggled to explain how American tank strength kept recovering despite confirmed kills from their own panzer units. The psychological impact on German forces proved as significant as the tactical advantages. Panzer crews who had counted specific Sherman tanks as destroyed found themselves facing identical vehicles in subsequent engagements. Tank commanders began recognizing individual American machines by their distinctive battle damage and field modifications, watching them return repeatedly to combat despite accumulating wounds that should have been fatal. Lieutenant Friedrich Kruger of the 2nd Panzer Division recorded his frustration in a letter home dated December 27, 1944. "We engaged the same American tanks day after day," he wrote. "Yesterday we put 3 rounds into a Sherman that has been fighting us for a week. Today it appeared again with metal patches welded over the holes. How is this possible? Our own tanks require days of repair for minor damage, yet these Americans seem to resurrect their dead machines overnight." The climactic moment came during the failed German attack on Bastogne on December 25th. As Panzer Lehr Division advanced through the village of Champs, they encountered a roadblock manned by 3 Sherman tanks from Combat Command B, 4th Armored Division. German intelligence had confirmed these specific tanks destroyed during fighting 3 days earlier. Burned-out hulks abandoned by their crews after taking direct hits from German anti-tank guns. But there they sat, blocking the main road with their guns trained on the advancing German column. All 3 Shermans showed visible signs of hasty repair work. Welded patches, replacement road wheels of different colors, and improvised armor additions that created distinctive silhouettes. The lead German tank commander hesitated, unsure whether he was seeing ghosts or facing genuine threats. His hesitation proved fatal. The supposedly destroyed Sherman tanks opened fire simultaneously, their hastily repaired guns functioning perfectly despite their cobbled-together appearance. Within minutes, 2 German panzers were burning, and the attack had stalled completely. As German forces regrouped for another assault, the 3 American tanks withdrew in perfect order, their repairs holding under combat stress. German commanders reviewing action reports from Christmas Day 1944 found themselves confronting an impossible tactical situation. Their opponents possessed some mysterious ability to restore destroyed equipment to full combat capability, using resources that shouldn't exist and techniques that violated established engineering principles. The careful German plans for eliminating American armor through systematic destruction were being undermined by mechanics who apparently worked miracles. The most dramatic demonstration of American battlefield maintenance superiority occurred during the final German offensive at Lake Balaton, Hungary, in March 1945. SS Oberfuhrer Herbert Gilmer's 6th Panzer Army launched Operation Spring Awakening with 400 tanks and assault guns, representing Germany's last operational armored reserve. Their opponents included elements of the American 6th Tank Destroyer Battalion and supporting Sherman companies that had been fighting continuously for months with minimal rear area maintenance support. The battle began at dawn on March 6th with massive German attacks against thinly held American positions. Within hours, dozens of Sherman tanks were reporting mechanical casualties from the intense combat. Damaged tracks, punctured fuel tanks, disabled weapon systems, and engine problems caused by the muddy Hungarian terrain. Traditional military logic suggested these units should withdraw for proper repairs, yielding the battlefield to German forces. Instead, something extraordinary happened. American maintenance crews established repair operations directly behind the fighting positions, often within direct observation of German forces. They worked in full view of enemy tanks, confident that speed and improvisation could overcome any technical challenge. German panzer commanders watched through their periscopes as American mechanics performed repairs that should have required specialized facilities and weeks of careful work. Technical Sergeant James Murphy of the 702nd Tank Battalion became legendary during this battle for his ability to resurrect apparently dead Sherman tanks. On March 8th, his repair team received a Sherman that had been hit 7 times by German anti-tank weapons. The main gun was disabled, the engine was leaking coolant from multiple punctures, 3 road wheels were completely destroyed, and the electrical system was shorting out from damaged wiring harnesses. Murphy's team assessed the damage in 15 minutes and began work immediately. They replaced the damaged road wheels with salvaged components from other destroyed tanks, using a cutting torch to remove stuck bolts that should have required precision tools. The punctured engine cooling system was repaired using radiator stop leak compound and metal patches fabricated from ammunition containers. Electrical problems were solved by completely rewiring the turret system using cables salvaged from knocked-out German vehicles. The most challenging repair involved the main gun, which had been struck directly by a German round that bent the barrel and damaged the elevation mechanism. Military manuals classified this type of damage as requiring complete factory rebuilding. Murphy disagreed. His team removed the damaged barrel using an improvised crane constructed from tank recovery equipment, then installed a replacement gun tube salvaged from another Sherman destroyed earlier in the battle. The entire repair process took 18 hours of continuous work under artillery fire. German forward observers could see the American repair operation clearly, but couldn't effectively target the constantly moving mechanics. When Murphy's reconstructed Sherman drove out of the repair area on March 9th, German intelligence officers recording the event noted that it appeared to be a completely different vehicle despite using the same hull. The psychological warfare impact proved devastating to German morale. SS tank crews, who had been taught that American equipment was inferior and poorly maintained, found themselves facing opponents who seemed capable of rebuilding destroyed tanks overnight. Radio intercepts recorded German commanders expressing disbelief and frustration as confirmed kills continued returning to battle with visible repairs. But full combat capability. The tactical implications became apparent during the German retreat that began on March 15th. As SS panzer units withdrew westward, they left behind dozens of immobilized tanks abandoned due to mechanical problems that American crews would have repaired immediately. German maintenance doctrine required specialized parts, proper facilities, and time that wasn't available during the chaotic retreat. American pursuit forces found perfectly serviceable German tanks abandoned simply because their crews lacked the confidence and training to attempt field repairs. The contrast became most apparent when American forces captured intact German maintenance facilities near Lake Balaton. These installations contained sophisticated equipment, precision tools, and carefully organized parts inventories that represented the pinnacle of military engineering. But they also contained dozens of German tanks awaiting repairs that American mechanics could have completed in hours using improvised methods and salvaged components. German prisoners captured during the retreat provided insights into their opponents' mysterious maintenance capabilities. Panzer crews reported watching American mechanics work with a speed and confidence that seemed impossible given their apparent lack of proper tools and facilities. Some German tank commanders admitted developing superstitious fears about American maintenance personnel, believing they possessed some form of technical magic that allowed them to resurrect destroyed equipment. The final irony came when American forces reached the Danube River in late March. German engineers had destroyed all bridges to prevent pursuit, but American tank crews simply drove their Shermans into the water and began fording operations using improvised waterproofing techniques. When several tanks suffered mechanical problems in mid-river, their crews performed emergency repairs while standing waist-deep in the current, completing procedures that German doctrine insisted required dry workshops and specialized equipment. SS Oberfuhrer Gilmer, captured while attempting to escape across the Austrian border, provided the most telling assessment of American battlefield maintenance capabilities. "We thought we were fighting tanks," he told his interrogators, "but we were actually fighting mechanics who happened to have tanks. Every time we destroyed their equipment, they simply built new machines from the wreckage. How do you defeat an enemy who can resurrect the dead?" The psychological impact on German forces proved more devastating than any tactical defeat. By early 1945, veteran panzer crews had developed what their officers termed Sherman anxiety, a persistent fear that destroyed American tanks would return to haunt them in subsequent battles. German tank commanders began requiring photographic confirmation of kills, unwilling to trust their own observations after repeatedly encountering supposedly dead Sherman tanks that had been mysteriously restored to combat effectiveness. This psychological warfare effect rippled through German armored units in ways that traditional combat assessments failed to capture. Tank crews who had once approached combat with confidence born from superior training and equipment now faced opponents who seemed to possess supernatural maintenance capabilities. The careful German planning process, which relied on accurate assessments of enemy strength and equipment status, became almost impossible when American tank availability couldn't be predicted using conventional military logic. German intelligence officers struggled to develop accurate battle damage assessments when their fundamental assumptions about tank vulnerability proved invalid. Standard Wehrmacht procedures counted tanks with major mechanical damage as permanently disabled, removing them from enemy strength estimates and tactical planning calculations. But American units consistently appeared with higher tank availability than German mathematics suggested was possible, creating persistent miscalculations in operational planning. The doctrinal implications forced fundamental changes in German tactical thinking. Panzer commanders who had previously accepted mission kills as sufficient victory conditions now understood they needed to achieve complete destruction to prevent American tanks from returning to combat. This requirement forced more aggressive tactics that exposed German forces to greater risk while consuming additional ammunition and time to ensure thorough target destruction. German maintenance personnel found themselves questioning their own professional competence when confronted with evidence of American repair capabilities. Highly trained technicians who had spent years mastering precision maintenance procedures watched enemy forces perform apparently impossible repairs using improvised methods and salvaged materials. The psychological impact on German morale proved profound as experts began doubting the effectiveness of their own training and procedures. The resource allocation consequences became apparent as German commands attempted to counter American maintenance advantages through increased spare parts production and forward deployment of maintenance units. These efforts diverted resources from combat operations while failing to address the fundamental philosophical differences that gave American forces their maintenance superiority. German logistics officers found themselves trapped in an escalating cycle of resource commitment that couldn't match American flexibility. Combat effectiveness evaluations revealed disturbing trends in German armored performance. Units that had previously dominated through superior equipment and training were losing tactical effectiveness as psychological pressure mounted. Tank crews became more cautious. Commanders hesitated to commit forces aggressively, and overall operational tempo decreased as German forces attempted to minimize exposure to American maintenance capabilities they couldn't understand or counter. The propaganda implications created additional problems for German military leadership. Official Wehrmacht publications continued portraying American equipment as inferior and poorly maintained, but frontline reports contradicted this narrative so consistently that troops began questioning official information sources. This credibility gap undermined morale and created doubt about other aspects of German military propaganda. Training modifications attempted to address American maintenance advantages through improved German battlefield repair capabilities. But these efforts came too late in the war to be effective and failed to address the fundamental cultural and design differences that gave American forces their superiority. German mechanics trained in precision procedures couldn't easily adapt to improvised repair methods that violated their professional training. The industrial implications became apparent as German armament production priorities shifted to counter American advantages. Resources were diverted from tank production to maintenance equipment and spare parts manufacturing, but these changes couldn't address the basic design philosophy differences that made Sherman tanks inherently more maintainable than German vehicles. The German emphasis on engineering perfection had created vulnerabilities that couldn't be corrected through production modifications. Command structure adjustments attempted to improve German battlefield maintenance through organizational changes and expanded maintenance personnel assignments. But these administrative solutions couldn't overcome the training, cultural, and design factors that gave American forces their maintenance advantages. German commanders found themselves fighting an enemy whose capabilities they understood poorly and couldn't effectively counter. The intelligence assessment challenges forced German headquarters to revise their fundamental assumptions about American armored capabilities. Standard enemy strength estimates became unreliable when American tank availability couldn't be predicted using conventional damage calculations. This uncertainty complicated operational planning and forced German commands to prepare for enemy capabilities that seemed to violate normal military logic. American commanders gradually recognized their battlefield maintenance capabilities as a decisive strategic advantage that extended far beyond simple tactical convenience. Tank availability rates consistently exceeded planning assumptions, allowing American armored units to maintain offensive pressure despite sustaining heavy mechanical casualties that should have forced operational pauses. This capability translated directly into sustained combat effectiveness that German forces couldn't match or counter. The operational implications proved profound as American tank units demonstrated unprecedented sustainability during extended campaigns. Traditional military planning assumed mechanical attrition would force periodic withdrawals for equipment rehabilitation, but American forces maintained combat effectiveness through continuous forward maintenance that kept tanks fighting despite accumulating damage. This capability allowed sustained offensive operations that wore down German resistance through relentless pressure. Strategic mobility advantages emerged as American units proved capable of operating independently from rear area support for extended periods. Tank companies that could maintain their own equipment required smaller logistical footprints and possessed greater tactical flexibility than opponents dependent on specialized maintenance facilities. This independence allowed more aggressive operational planning and reduced vulnerability to enemy interdiction of supply lines. The training validation proved complete as American battlefield maintenance capabilities confirmed the wisdom of cross-training tank crews in mechanical procedures. Units that had invested time and resources in teaching all personnel basic repair skills found themselves with decisive advantages over opponents who maintained rigid specialization between operators and maintenance personnel. The American approach of treating every tanker as a potential mechanic had created capabilities that traditional military doctrine hadn't anticipated. Production philosophy, vindication emerged as combat experience confirmed the superiority of American design approaches that prioritized maintainability over engineering perfection. Sherman tanks that had been criticized for mechanical simplicity proved far more combat effective than technically superior German vehicles that couldn't be maintained. Under battlefield conditions. The American emphasis on standardization and repairability had created decisive tactical advantages. Intelligence advantages developed as American forces gained detailed understanding of German maintenance limitations through captured equipment and prisoner interrogations. This knowledge allowed American commanders to exploit German vulnerabilities by targeting maintenance facilities, interdicting spare parts supplies, and timing operations to maximize stress on German repair capabilities. Understanding enemy maintenance weaknesses became a significant tactical advantage. The psychological warfare implications proved as important as mechanical advantages. American tank crews developed supreme confidence in their equipment and capabilities, knowing they could repair almost any damage and return to combat quickly. This confidence translated into more aggressive tactics, higher risk tolerance, and sustained morale despite heavy combat casualties. German forces noted American tankers seemed almost reckless in their willingness to accept combat damage. Economic efficiency advantages became apparent as American battlefield maintenance capabilities reduced overall equipment requirements while maintaining higher combat effectiveness. Units that could repair and return damaged tanks to service quickly required fewer replacement vehicles than opponents who lost tanks permanently due to minor mechanical damage. This efficiency multiplied American industrial advantages and reduced logistical requirements. Combat experience validation confirmed American training methods as superior to German approaches that separated maintenance responsibilities from operational personnel. Tank crews who understood their equipment intimately performed better in combat, made fewer tactical errors, and showed greater initiative when facing unexpected situations. The integration of technical and tactical training had created more capable overall soldiers. The innovation culture that encouraged American field modifications and improvised repairs proved decisive in creating solutions to tactical problems that formal engineering couldn't address quickly enough. Tank crews who felt empowered to modify their equipment developed creative solutions to combat challenges while maintaining full operational capability. This flexibility gave American forces consistent advantages over opponents constrained by rigid procedures. Logistical multiplication effects emerged as improved tank availability reduced pressure on replacement vehicle production and shipping. Units that could maintain higher percentages of their authorized equipment in operational condition required fewer reinforcements while maintaining superior combat effectiveness. This efficiency freed production capacity for other military requirements while maintaining armored combat power. The tactical flexibility advantages proved decisive as American tank units demonstrated capability to operate effectively under conditions that would have immobilized German forces. Units that could maintain their equipment independently possessed greater operational reach, required less rear area support, and could sustain combat operations longer than opponents dependent on specialized maintenance infrastructure. This capability translated directly into battlefield success. International influence spread as Allied forces observed American maintenance capabilities and began adopting similar training and organizational approaches. British, Canadian, and other Allied tank units modified their procedures to incorporate American innovations in battlefield maintenance, multiplying the strategic advantages throughout Allied armored forces and creating additional pressure on German capabilities. The story of American battlefield maintenance superiority reveals profound truths about warfare, innovation, and human adaptability that extend far beyond the mechanical details of tank repair. What began as pragmatic engineering decisions, designing tanks for maintainability rather than perfection, evolved into decisive strategic advantages that influenced the entire course of armored warfare in World War II. The German obsession with engineering perfection, while admirable in peacetime, created vulnerabilities that American pragmatism exploited ruthlessly. By prioritizing complex precision over simple reliability, German designers had unknowingly constructed beautiful machines that couldn't survive the harsh realities of sustained combat. Their tanks represented pinnacles of mechanical engineering that proved less combat effective than supposedly inferior American designs that could be repaired by ordinary soldiers using improvised methods. The human element proved equally crucial. American military culture that encouraged improvisation, cross-training, and individual initiative created capabilities that formal German training procedures couldn't match. Tank crews who felt empowered to solve problems creatively developed solutions that rigid adherence to official procedures would never have discovered. The American willingness to blur traditional boundaries between operators and mechanics had created hybrid soldier technicians whose capabilities exceeded the sum of their individual specializations. Perhaps most importantly, this story demonstrates how industrial philosophy translates directly into battlefield effectiveness. Henry Ford's assembly line principles, when applied to military equipment design, created tanks that could be manufactured quickly, maintained easily, and repaired under impossible conditions. The American embrace of standardization and simplification, often criticized as crude compared to German engineering sophistication, proved decisively superior when tested under combat conditions. The psychological dimensions cannot be overlooked. German tank crews who had dominated early campaigns through superior training and equipment found themselves facing opponents who refused to accept mechanical defeat. The sight of supposedly destroyed Sherman tanks returning to battle day after day created doubts and fears that undermined German tactical effectiveness more than any direct combat losses. American mechanics working under fire had become psychological warriors whose mere presence influenced enemy behavior. The lessons remain relevant today as military forces grapple with complex equipment that requires specialized maintenance in hostile environments. The tension between engineering perfection and battlefield practicality continues challenging military planners who must balance technical sophistication against operational sustainability. The American example from World War II suggests that designs optimized for maintainability often prove more combat effective than technically superior alternatives that cannot be sustained under battlefield conditions. Ultimately, those American mechanics crawling under Sherman tanks while German artillery searched for their positions represented something larger than individual courage or technical competence. They embodied an entire philosophical approach to warfare that valued practical solutions over theoretical perfection, improvisation over rigid procedures, and human adaptability over mechanical precision. Their legacy lives on in every military unit that prioritizes battlefield effectiveness over engineering elegance, reminding us that wars are won not by perfect machines, but by imperfect humans who refuse to accept defeat.